Hello everyone, welcome to EEEE lecture number 7A. Today we are going to discuss about source transformation. So let's say you have a circuit with a DC source Vs and a series resistance Rs. Now according to source transformation, this gets converted into a current source with a parallel resistance. Alright, now this is point A and B, this is A, this is B. This will be named as Is and this is Rs. So Rs value will be same. Rs value is, let's say this value is 1 ohm and this voltage source value is 5 volt. So this value will be 1 ohm itself. What about the voltage, what about the current source? Current source will be voltage source divided by resistance. So here it will be 5 amperes only. Alright. And the direction of the current is directed from negative to positive. Oh, sorry. Negative to positive. Alright. So this is what happens when we apply source transformation to a voltage source with a series resistance. It gets converted into a current source with a parallel resistance. Now let us do the other way around. Let's say you have a current source in parallel with resistor Rs. So if you apply source transformation over here, it gets converted into a voltage source in series with a resistance Rs. Now to determine the values of this voltage source Vs and Rs. So basically let's say that this Rs is 2 ohm and this current source value is 2 ampere. So Rs value will be same 2 ohms and the current source value will voltage source value will be Vs is Is into Rs. So that will be 2 ampere into 2 ohm, that will be 4 volt. Alright. So this is how we can use source transformation to simplify the network and solve the resistive circuits consisting of resistor, current source and voltage source. Now let us see one numerical for this example. So we'll solve this numerical number 1. We need to find the current flowing through 4 ohm resistance. So current flowing through this 4 ohm resistance we need to find out. So let's say, this is the part we have marked 4 ohm resistance. Alright. So while you reduce the network, note that 4 ohm resistance shouldn't be disturbed at all. Alright. Now let's apply source transformation and simplify this network and find the current flowing through 4 ohm resistance. So let me start by writing solution. Let me reduce the font a little bit. Yeah. So let us start. To the first scenario over here is, can you see this 5 ampere current source that is in parallel with 2 ohms volt 5 ampere current source is parallel with 2 ohm resistance. So this gets converted into a voltage source in series with a resistance. So let me draw that. So this gets converted into a voltage source. Current flows from negative to positive and a series resistance of 2 ohms. What will be the value of the voltage source? Current into resistance, that will be 5 ampere into 2 ohm, that will be 10 volt. Alright, let me draw the remaining part of the circuit. So over here we have 6 volt. Then again we have a current source. This is 6 volt. Then there will be a current source and then will be a parallel resistance of 4 ohms. Alright. Now, if you see carefully, there are two voltage sources in series. Let me write it, the polarity. This is minus plus, this is plus minus. So whenever two voltage sources are in series, they get added up. All right, let me draw over here. All right, so but the polarity is different. So this is 10 volt, and if you go over here, it will be if you go from below to top, there is a rise in potential, and here if you go from left to right, there is fall in potential. So it will be 10 volt minus 6 volt, that will be equal to 4 volt. All right, so let me redraw the circuit. We have added the two voltage sources in series. All right, so we have the following. We have 4 volt, then we have 2 ohm resistance, then we have 2 ampere current source, and then in parallel we have a resistance of 4 ohm. This is ground actually. So this is 4 ohm. Alright. So this gets converted into a 4 volt voltage source. Now we have added the voltage sources over here. All right, we have added the voltage sources, but the polarity of 6 volt voltage source was negative, so that's why it is 10 minus 6 volt. That will be 4 volt. Now, if you see this carefully, now we have a 4 volt voltage source over here, and next we have a 2 ohm resistance. So these two uh, voltage source in series with a resistance will become a current source with parallel with a resistance. So let's do that. Okay, I hope you're following. So over here we'll go to this now, network. So here this voltage source is replaced by a current source. Direction will be from bottom to top, and it will be replaced with a parallel resistance of 2 ohm. What will be the value of this voltage source? What this current source? 4 volt divided by 2 ohm. That will be 2 amperes. All right. And then we have another current source, and then we have a resistance. This current source value is 2 ampere, 2 ampere, and this is my 4 ohm resistance. All right. So this is what we get so far. Now, if you see carefully, we have two current sources which are connected in parallel. So they get added up. So I have 2 ampere current source and another 2 ampere current source. They get added up. So 2 ampere plus 2 ampere becomes 4 ampere current source because the directions are same. So this network will simplify it further to this network over here. So you have a 4 ampere current source. Current source in parallel gets added up, and we have two resistance over here in parallel. Remember, we should not consider solving further 4 ohm resistance because we want to find the current through 4 ohm resistance. Alright, so the circuits gets converted to this network. Now, either you can apply a current division rule or you can simplify this further. So if you see carefully, we have a current source in parallel with a series resistance. So that gets converted into a voltage source with a series resistance. Okay, so this value of resistance will be 2 ohm. What will be the voltage source value? 4 ampere into 2 ohm. That will be 8 volt. And this will be 4 ohm. Got it? And now in this circuit, if I find the value of current, that will be the current through 4 ohm resistance. So that will be 8 volt divided by 4 plus 2. That will be 8 by 6. That will be 4 by 3 amperes. So this is my value of my current flowing through 4 ohm resistance is 4 by 3 amperes. That is 1.333. Alright. So this is how we can apply a simple source transformation and find the value of the current flowing through the 4 ohm resistance. Now let us quickly check this with LTspice and let's see whether we get the same answer. So I've already opened the LTspice window. Let me reduce this. Alright. So let's build a circuit using LTspice quickly. So here is my component. This is my LTspice workspace. From component, I'll select current. I'll reverse the current by pressing Ctrl R. I'll place two current sources and then I require resistances, one over here and one over here. And then I require a voltage source. So I'll type voltage and I press Ctrl R. So my voltage source will be over here. Okay, let me select it. Yeah. Now I'll connect them with the wire quickly. Alright. Let me connect the entire circuit. We will connect this current source in this fashion and this resistance over here. Remember in LTspice we need to connect the ground always. So here is my ground. I'll connect it with the wire. Alright, now let me select zoom to extend. The entire circuit has come. Now let me give the value. This is 5 ampere. This will be 2 ohm. This will be 6 volt. This current source value is 2 ampere. This resistance is 4 ohm. We need to find the current through 4 ohm resistance. Now I am not be applying source transformation, but I directly finding the current using LTspice. So current flowing through 4 ohm resistance is nothing but current flowing through R2. So if you can see carefully, current flowing through R2 is 1.33. And what did we get? 4 by 3, that is 1.333. All right. So indeed the current flowing through the 4 ohm resistance is correct, that is 1.333 or 4 by 3 amperes. All right. In this fashion we can check the circuit in LTspice. Now let us move on to the next numerical. That also will solve it using source transformation. So numerical number 2 is we need to find current flowing through 4 ohm resistance and voltage across 4 ohm resistance. So basically over here we need to find, this is my 4 ohm resistance which should not be disturbed at all. So I need to find the current flowing through 4 ohm and the voltage across this 4 ohm resistance. Alright. So this 4 ohm resistance should not be converted or disturbed at all throughout the numerical. Alright. So let us begin. Let me write solution. Alright. So what's the first thing over here? So start with the extremely opposite side to this 4 ohm resistance. So what do you see over here is, we see here a 6 volt voltage source in series with a 3 ohm resistance. So that gets converted into a current source with a parallel resistance. So let's do that. So let me write over here. So this gets converted into a current source, direction going from negative to positive, and in parallel we have a resistance of 3 ohm. What will be the value of this current source? It will be 6 volt divided by 3 ohm, and that comes out to be 2 amperes. Now remaining circuit will draw as it is quickly. This will be 2 ohm, 6 ohm. Let me expand it a bit. This will be 3 ampere, and this will be 1 ohm. You remember many students have a temptation of joining them together and making it 5 ohm. We don't need to do that. We cannot do that because we need to find the current through 4 ohm resistance. So do not merge them together. Alright. So next you see over here is two resistance are in parallel. So we need to find the equivalent resistance. So it will be 3 ohm parallel to 6 ohm. If you work it out, it will be around 2 ohms. So let me redraw the network now. Alright. So I will draw this again over here. So we have 2 ampere current source, and then we have a single resistor now of 2 ohm. Then we have 2 ohm over here. This is my current source 3 ampere, and these are my two resistances, that is 4 ohm and 1 ohm. Alright. Now we need to concentrate on this network and simplify it further. So let's do that. So if you see carefully, we have a current source in parallel with a resistance, 2 ohms resistance. So this gets converted into a voltage source with a series resistance. So let's do that. So this is my voltage source. Value of the voltage source is current into resistance. That will be 4 volt. Then we'll be having a series resistance of 2 ohm. There will be another resistance 2 ohm over here, right? Then there will be a current source, and then there will be 1 ohm in series with 4 ohm resistance. This is ground actually. This is 4 ohm, 1 ohm, and 3 amperes. Alright. Now, if you see carefully, these two resistances are in series. So basically, what they become 2 ohm plus 2 ohm is equal to 4 ohm. So in the next part, we will be directly converting this part over here into 4 ohm resistance. Let's skip one step. So this is basically 4 ohm resistance. So now what we have a 4 volt voltage source in series with a 4 ohm resistance. So that's get converted into a current source parallel to this 4 ohm resistance. So let's do that transformation now. So I'll be doing it over here. So this gets converted into a current source going from negative to positive. What's the value? 4 volt divided by 4 ohm. That will be 1 ampere. In parallel with the resistance value is 4 ohm because this 2 ohm and 2 ohm are bunched together. Then we have another current source of 3 amperes, and then we have a 2 resistance connected in series, and its values are 1 ohm and 4 ohm. Remember, we cannot disturb this 4 ohm resistance, okay, throughout the circuit, because we need to find the current through 4 amperes. Now if you see carefully, this 1 ampere current source and this 3 ampere current source are connected in parallel. Okay, so whenever the current sources are connected in parallel, they get added up. So this 1 ampere plus 3 ampere become 4 amperes. So let me redraw the circuit now again. So I have a single current source of 4 ampere. In parallel I have a resistance of 4 ohm. Then I have two resistance connected in series of 1 ohm and 4 ohm. Alright. Now again I cannot disturb this circuitry. 4 ohm I cannot change it at all, neither I can convert it or connect it in series or parallel combination. Now what I will do is I'll convert this current source and this parallel resistance into a voltage source. So let's do that. So this gets converted into a voltage source in series with resistance 4 ohm resistance, and then we have 1 ohm and 4 ohm resistance. So this value of the current voltage source will be 4 ampere into 1 ohm, that will be 4 volt. All right. Okay, so now this is 1 ohm resistance. Let me connect it over here. So now if you find the current through the circuit, if you find the current through 4 ohm resistance, because the current flowing through all the resistance over here are same, almost the same, so we can use a simple voltage division and find the value of oh sorry, wait a sec, this is not 1 ohm. So basically we are converting this 4 volt and 4 ohm resistance. So it will be, what will be the value of the voltage source? Be careful over here. We are converting a 4 ampere and a 4 ohm resistance. So 4 ampere multiplied by 4 ohm, that will be 16 volt. Okay, so current flowing through 4 ohm resistance will be this 4 ohm resistance. Okay, this 4 ohm resistance will be 16 volt divided by 4 plus 1 plus 4, because all these resistances are connected in um, series. So it will be 16 by 9 amperes. Okay, so that will be the value of the current flowing through 4 ohm resistance. Now we need to calculate the voltage across 4 ohm resistance. So how will you find the voltage? So voltage across this 4 ohm resistance will be current, this current into the resistance 4 ohm. So that will be 16 by 9 into 4 ohm. That will be 69 by 4 volts. Alright. So this is the value of the current and the voltage. This is the value of the current and the voltage. Alright. So this is how we can solve by using simple source transformation. We can simplify the network, in either into a voltage source in series with a resistance or a simple current source with parallel with a resistance. All right. So this we complete over here, lecture number 7A. Next time we will start with lecture number 7B and we'll start with Thevenin's theorem. So until then, have a good day and thank you.